Welcome to the demonstration of the Redis clients. This is a project that enables buyers and sellers to trade Redis instances. To start off the demonstration, we're going to need to have a local version of the Ethereum blockchain running, and we can do that with Anvil by running the command make run local Anvil. And we're also going to have, for the sake of our transaction, a third-party oracle to arbitrate over all transactions. And before we begin to demo how the exact transaction flow will happen, we need to have an oracle running in the background to arbitrate over transactions. So now let's go into a different screen. And what we have here is a bunch of terminal screens. The two on the left, they represent what the seller would see and the seller's perspective. And the two on the right represent what the buyer would see and the buyer's perspective. In a production setting, these would likely be these processes would likely be running on completely separate computers. But for the sake of the demonstration, to make everything a little bit more easily digestible, we're going to have them all on one screen. So the seller would need to run a local storefront, and they would also need to run a local server on a server-side proxy, which will enable the user to access their underlying Redis instances. And the buyer will be able to access their Redis instances only through the server-side proxy, so that we can ensure that they have the proper authorization for the Redis instances. And yeah, so with that being said, let's just imagine like a local and some sort of buyer comes by and they want to buy some Redis instances. They're going to run a command like make run local buy. Make run local buy, the buy happened, and it'll give you a statement UID, which you want to use in order to launch your client-side proxy. So down here, we have the command to run a client-side proxy, and through this client-side proxy, you can actually access your underlying Redis instance, and we can show that with the command uh, by sending bytes to this client-side proxy with the netcat command. And you can see we sent ping and we got pong back. And basically you can use netcat or you just send bytes to your client-side proxy. It'll attach some signature and then send it to the server-side proxy. And you can do some authorization on that and ensure like you could actually access your Redis instances via that flow. Now, this was a successful transaction. So when the seller, you can imagine, um, let's just check the uptime, the third-party Oracle Arbiter. Uh, and yeah, so the Oracle Arbiter determined that there was 100% uptime for this Redis provision. So that means that we should be able to collect escrow for this because the seller met the 95% demand of the buyer. So the seller could go and collect their escrow like so. And you can see that the escrow collected successfully and you get a receipt that comes with it. Now, of course, this is a very idealistic situation, and you can imagine that not in all transactions will the seller actually honor their end of the agreement. For whatever reason, they might not meet the demanded uptime or like others' demands, but that's what the third-party Oracle Arbiter is there for. And the Oracle Arbiter can also determine if the seller did not meet the buyer's demands. So let's say, of course, the seller will still have to have their storefront up and running, as well as their server-side proxy. And let's say we have a buyer that comes and just runs a local buy. So they bought their Redis instance. In the meantime, you can see that the third-party Oracle Arbiter is continuously pinging this. But let's say if the server-side proxy crashes, we actually have no way to access our underlying Redis instance, right? And this is really bad. And even if the seller somehow just like, reboots it and it comes back up, there was pretty a large portion of time when we actually had no way to actually access the underlying Redis instance that we had bought. So we're going to see at the end of this transaction, which is a very shortened, like 30-second transaction, just for the sake of the demo, the seller did not meet the uptime demands of the buyer. The buyer demanded 95% uptime, whereas the seller only provided 67% uptime. What this means is that when the seller should try to collect the escrow, will not actually be able to, we should not be able to do so because we did not meet the demand. And we can go see that for this particular statement, when the seller tries to run the escrow collection script, it fails. It says waiting for arbiter decision on fulfillment. Arbiter decided false, escrow not collected. So the arbiter, because it decided false, um, we were not actually able to collect the escrow. Um, So yeah, that's pretty much it, and that shows how you can actually have a decentralized Redis provision system where all the transactions happen on the blockchain, and you can have a third-party oracle to ensure that these transactions are honored, and pretty much anyone can become a seller of Redis instances.